So the name of this section is solving trigonometric equations, and I got the second problem on here, and I kind of feel like this is one of the harder problems on the whole section, but so I'm not sure why it's number two, but I'm going to show you kind of the idea, and then I'm going to do a couple other examples for you. This is all about inverse, okay, and you see I have the unit circle up there because this is also kind of like a unit circle. These are unit circle problems. So like I said, this is kind of a weird one. The directions are asking for the x-intercepts, and those are here and here. And what that is telling us is that the y value is 0. And so then what we would say is sine of pi x plus cosine of pi x equals 0. And so like I said, this is kind of like a hard problem to start off with, but what we're thinking of is values of x so that when we take the sine of it and the cosine of it, they basically cancel each other out and add to 0. And so you're not thinking of the angles. This is, like I said before, this is kind of like an inverse trig problem. So we're kind of thinking of the answers. And so the question is, what angle produces same but opposite values of cosine and sine? And so if you're looking across the around the unit circle, what you should kind of zero in on are the places that cosine and sine give you the same values. Okay, and so that only happens on the 45 degrees. So at pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. Since we're adding and they need to both cancel, we need to concentrate on the second and the fourth quadrant because the signs are opposite on these radical 2 over 2's. So we want to take the sine, like we're going around, we'll just start with this one. We want to take the sine of 3 pi over 4 because we know that the sine of 3 pi over 4 will give us radical 2 over 2. But right, we also have this thing going on here with the pi times x. So the way we're going to do that is say, well, I know, this is this kind of algebra stuff. I know that I want this value to give me, or to be, sorry, 3 pi over 4. Okay, so don't get mixed up, right? Because we need an angle to be put in here to take the sine of the angle to get radical 2 over 2. And so what is that angle? Well, we wish we could just put in 3 pi over 4, but then we have this pi over here. So to find x, we're going to divide by pi. Oops. And say our x value is 3/4. Okay, so again, you can always plug in values to check them. If we say 3/4 works, and again, the reason we took 3/4 is because 3 pi over 4 gives us a negative radical 2 over 2 and a positive radical 2 over 2. So if we plug this back in, it'd be 3/4 times pi, which would be 3 pi over 4. So the sine of 3 pi over 4 is right, so we'll do it this way. Sine of 3 pi over 4 equals radical 2 over 2. And then, of course, we'd have to plug this same value over here. So 3/4 times pi is still 3 pi over 4. And then if we took the cosine of 3 pi over 4, we would get negative radical 2 over 2. And if we add those together, we get 0. So we just found this 0, okay? And I didn't mark the other one, but we only have 3 that we have to find because we're only doing it on the graph. So we just found that one. And so then where is another value? Okay, so this value must be all the way around to here, and so we would need 7 pi over 4. And so we would go through the same process. So we're still going to use this blue equation, but this time we're going to say, like this is the first one. So then the second one, we would say, okay, well, we need this value, this angle, to be 7 pi over 4. And so then again, we divide by pi, and we'd say, okay, so our x value would be 7 over 4. Okay, and you can check it the same way. I'm not going to do that just so you don't have to watch that again. But right, if we plugged in 7 over 4 here, we'd be finding the sine of pi over, we'd be finding sine of 7 pi over 4 plus cosine of 7 pi over 4. And again, that would give us a negative radical 2 over 2 and a radical 2 over 2. Okay, so then that's the next one here. Okay, and so then the only other one is this one in the negative direction. So we would have to go in the negative direction from our initial starting spot here to here. And so that would be negative pi over 4. And again, we're going to use the same blue equation here. And set it up the exact same way. So then we want this value to give us negative pi over 4. And so then we would divide by pi and get negative 1/4. Okay, and then you can check it the same way. So again, I think that's like one of the harder problems on there just because you got a lot to think about. And basically that's what we're doing, this whole thought process here. You're not always going to have a graph. They're going to give you usually a range, usually 0 to 2 pi or negative 2 pi to 2 pi or something. But this thought process here is the whole key. What angle do I need to be taking of in here? And usually you don't have, well, at the beginning you don't have two, you could always have as many as they want to give you. So this one's a little bit more straightforward, and we're looking for the solution to this equation. And they're just equations, so we're going to move things away from the variable we're trying to find. So I'm going to add 1. We have 2 sine of x equals 1. We're going to divide by 2, and we get sine equals 1/2. Okay, so this is just an inverse problem. You could punch in your calculator, inverse sine of 1/2 and get a decimal approximation, but you're really being asked to find these exact values all the way around. Okay, so where or what angle produces a sine of 1/2, right? Well, this one actually tells you, a little reminder here, sines are y values. So as we're going on, we can see our first y value that happens to be 1/2 is pi over 6. So then one of our answers is going to be pi over 6. And again, the reasoning for that is that if we put pi over 6 in here, we would get 1/2. And so that's an easy thing to check on your calculator. Of course, hopefully you're looking at a unit circle. But what angle, when we take the sine of it, gives us 1/2? Pi over 6. Okay, but you do have to kind of watch out, because we would go around and then we see again, that this y value is 1/2. So also 5 pi over 6 would give us 1/2, right? So sine of pi over 6 gives us 1/2, and sine of 5 pi over 6 gives you 1/2 also. But that's not quite the answer, because you can spin around the unit circle as many times as you want, and every time you spin around and you get to pi over 6 or its equivalent, the answer would be 1/2. So we're not done with these answers yet. The same thing applies to 5 pi over 6. So every time we go around a full circle, then it counts again. So we would say, all right, our answer for the first one would be pi over 6 plus 2 pi. And then, we could keep going and do another 2 pi, and another 2 pi, and another 2 pi. And so then the way we can take care of that, fact that we could just spin around an infinite amount of times is we say 2 pi times n. And, I think in the back of the book they don't really say this every time. And I think they do 2n pi. But, really what you're saying is where n is a whole number or a positive integer. Remember, whole numbers are 1, 2, 3, 4, 5. I guess whole numbers include 0. Sorry. So really we're talking about natural numbers. Natural numbers are 1, 2, 3, 4, 5, etc., etc. Okay? And then the same thing applies for 5 pi over 6, right? We get to 5 pi over 6. Sine of 5 pi over 6 is 1/2. But then when we go around 2 pi again, it's 1/2. We go around 2 pi again, it's 1/2. We go around 2 pi again, it's 1/2. So then we would say plus 2 pi n. Okay, so just a little bit harder problem here. Think about things that we've already talked about. Tangent squared means we should be looking for 2 answers on this. It doesn't mean we'll find 2 distinct answers, but we do need to think about 2 different answers. Everything so far has moved away from the variable. We can't get inside with that 3x inside here, right, until we do the inverse tangent. But again, we're going to think about this more like we did the first problem, number 2 there. But do understand that tangent squared is the same as tangent squared this way. So now we can take the square root. Remember, when you're taking a square root, you need a positive and a negative. So that's where our 2 potential answers are going to come from. And now what we want to do is figure out the angle, tangent of what angle gives us radical 3 or negative radical 3. So this is where, if you really had all your unit circle memorized, this gets pretty easy. If you don't, then you got a little bit of work to do. Remember that tangent is sine over cosine, and we're looking for a sine divided by a cosine coordinate that would yield a radical 3 or a negative radical 3. So, right, sine is y. So, you'd have to test them out, but you should be looking at these 2, but this is the correct one because it's sine over cosine, and I'll do kind of how that works out over here. So, right, sine over cosine, right, this is your keep, change, flip. So then this is really and that's where the radical 3 comes from. So, right, what is that angle? That angle is pi over 3. Excuse me. So the first thing we would say is, let's just take care of this situation first. So then we would say, okay, we want this angle that we're taking the tangent of. One of our options is pi over 3. And then if I divide by 3, what I would need to plug in is pi over 9. All right, so I'm going to come back and we're going to make sure we get all of the other ones for that one here in a second. But let's find the other positive radical 3 over 3. Okay, so this was a positive divided by a positive. These are negatives divided by negatives. And so we need the same situation, right, where the y is divided by the x. So then we're down here, right? Negative radical 3 over 2 divided by negative 1/2 would give us a positive radical 3. So another place would be 4 pi radical 3. So then we would have this. And then to divide by 3, and we would get 4 pi over 9. Okay, and then the negatives would be found the same way. Right, we still need our y value to be radical 3 over 2. So then we would be up here. That would give us a negative radical 3. And then down here would be the other negative radical 3. Okay, so then we're talking about 2 pi over 3 and 5 pi over 3. Okay, so now before, this would be a fine way to do it. Okay, so, right, we have all 4 situations going around, and then we could say, well, we can add 2 pi n to each of these. Right, for the same explanation as we did in the last problem. Oh, shoot. Okay, and that would cover everything, right? And so again, what that would mean is or what we're saying there is, here's our first instance. Every time we go 2 pi, every time we go 2 pi, every time we go 2 pi, and it keeps on adding up. And so we're doing that for each of these along the way. But the other thing that you could notice is that, and the way they're going to answer it in the back of the book is, well, this one is 180 degrees from this one, or a difference of pi. So instead of writing so instead of writing it that way, what we can do is just look at our first instance when it gave us the positive radical 3, which was at pi over 3, and then add a pi to that. And so then now when we divide by 3, we would say that x equals pi over 9 plus pi over 3, n, right? Pi n over 3, I guess. Right, and again, that's just so then we're just adding a third to every pi over 9, and that will take care of all of the positives. And then the same thing, the first negative radical 3 we got was at 2 pi over 3, and we could just add a pi to that. And so then we could say that it's 2 pi over 9 plus pi n over 3, right? We just divided everything by 3 there. All right, so on this one, it's kind of like they already factored for you. And so remember, when you have a factored problem that is already set equal to 0, you can just set each of the factors equal to 0. And then solve each individually, right? So we're looking for where tangent is 0, okay, and that's where sine is 0. And so the first place is right here. You don't even have to go anywhere. So then our first place would be so then x equals 0. Okay, and then the next place would be around here at pi. And so then we would keep this going, right, around like this as we keep going. Every time we got to 0, pi, 2 pi, etc., it would keep giving us a tangent of 0. Okay, and so we're going to kind of use the same. I'm going to leave that one alone. I'm not sure how they're going to want you to answer it, but I'm going to leave that one alone. And then I'm going to say, all right, I also want where 3x equals pi plus every time we get around pi, right? That would take care of our 2 pi and then our 3 pi and our 4 pi. And so then x would also be for this one okay, so in the back of the book they just have this all of this red. Let me get this one out of the way here. Oh, of course. Good grief. All right, hold on. No. All right, I'll rewrite it then. So in the back of the book, they don't give both of these instances, okay? They just say their answer for the first tangent 3x is x equals pi n over 3, okay? And that's basically what we're doing. When I just say x equals 0 and then I go from here, I could just say it's this, because when n equals 0, so then it wouldn't be natural numbers, it would be the whole numbers, right? Plus 0, that would give you the 0, and then when it was 1, it would give you the pi over 3, and then it would just look like this from on. So, these are fine. This is a little bit more condensed. And so let's do the second part here. We'll still be able to see it. So, right, so we're going to add 1 to the other side. So then we're going to have tangent of x equals 1. Okay, and so that's where the sine and the cosine are the same value. And again, that's going to only happen at the 45 degrees, so pi over 4, etc. And so then you would say, okay, so x could be pi over 4 plus every other time it gives us a positive 1. So let's go back up and check. Right, so we're over positive 1 here. We come to here, careful, that's a negative 1. So we come all the way over here to a negative divided by a negative. And so then it's every 180 degrees or every pi. So what we're going to add then is we're adding a pi however many times we need to. All right, so take a look at those, and I'll make another short video over the factoring, and I'll put that one on there too. So make sure you guys are asking.